Imagine discovering bones so old that they challenge everything archaeologists have spent decades defending. That's exactly what happened when paleontologists began examining mastodon remains pulled from the ground in Southern California. What they found buried deep in the earth would force the entire scientific community to confront an uncomfortable question. What if we've been wrong about human history all along? The story begins in 1992 on what seemed like an ordinary day. Construction crews were working on a highway expansion project near San Diego, California, when their equipment unearthed something unusual. Beneath the surface of the earth lay the scattered remains of an ancient mastodon, a massive elephant-like creature that had roamed North America during the Ice Age. But this wasn't just any paleontological discovery. What made this site extraordinary would only become clear years later, after decades of meticulous analysis and scientific scrutiny. The construction site became known as the Cerruti Mastodon Site, named after Richard Cerruti, one of the paleontologists from the San Diego Natural History Museum who recognized the significance of what had been uncovered. When Cerruti and his team first examined the bones, something seemed unusual. The mastodon remains weren't scattered randomly as you might expect from natural decay or predation. Instead, they appeared to have been deliberately broken. Alongside these fractured bones lay stone tools, cobblestones, that bore unmistakable signs of use, complete with wear patterns and impact marks that suggested they'd been used as hammers and anvils. But here's where things get truly controversial. When researchers ran the dating tests using advanced uranium-thorium dating technology, the results shocked everyone. The bones were approximately 130,700 years old, give or take 9,400 years. If correct, this would mean humans were in North America during a period when conventional archaeology said they shouldn't have been there at all. To understand why this discovery is so revolutionary, you need to know what archaeologists believed before the Cerruti Mastodon site was announced. For decades, the scientific consensus had been remarkably stable. Most scholars agreed that humans between 13,000 and 15,000 years ago. This was the Clovis first theory, named after the distinctive stone tools found at archaeological sites in Clovis, New Mexico. These fluted spear points became the calling card of early American civilization. According to this widely accepted timeline, humans migrated across the Bering Land Bridge during the last Ice Age, rapidly spreading throughout North and South America within just a few centuries. This theory had been the bedrock of American archaeology for generations. It was taught in universities, published in textbooks, and defended vigorously by the establishment. The problem was that mounting evidence had been chipping away at this certainty for decades. Starting in the 1970s, archaeologists began discovering sites that seemed to predate the Clovis culture. There was Meadowcroft Rock Shelter in Pennsylvania, with evidence suggesting human occupation dating back much further. There was Monteverde in Chile, where Tom Dillahay found what appeared to be a fully occupied settlement with tools, hearths, and wooden structures dating to around 14,500 years ago. These discoveries sparked fierce debate, with some researchers accepting them as legitimate pre-Clovis sites while others remained skeptical. But the Cerruti Mastodon site was different in scale. While previous pre-Clovis sites pushed the timeline back by several thousand years, the Cerruti site claimed to push it back by over 115,000 years. It wasn't an incremental shift, it was a fundamental overhaul of everything archaeologists thought they understood. In 2017, after more than 2 decades of research, the findings were published in the prestigious journal Nature. The paper was authored by Stephen Holen, a paleontologist from the Center for American Paleolithic Research, along with Thomas Desmarais from the San Diego Natural History Museum, and a team of respected scientists from the United States and Australia. In the press conference announcing the discovery, Desmarais was candid about the audacity of their claim. He stated that it made their site the oldest archaeological site in the Americas by a factor of 10. I realize that 130,000 years is a really old date, he said, and of course, extraordinary claims like this require extraordinary evidence, and we feel like the Cerruti Mastodon site presents this evidence. The research team laid out their case methodically. First, they argued that the spiral fracture patterns on the mastodon bones indicated they were broken soon after the animal died, not thousands of years later. They pointed out that only the long bones showed fractures, while more delicate bones, like ribs, remained intact. If heavy equipment had caused the breakage, surely the fragile ribs would have been broken too. The team also noted that the most relevant bone fragments were covered in thick crusts of pedogenic carbonate, proving that the breakage had occurred far longer ago than any recent disturbance. Second, they presented the stone tools themselves as evidence of human intentionality. The cobblestones showed unmistakable wear patterns on their surfaces, consistent with being used as hammers and anvils. The bones showed signs of systematic reduction, suggesting someone was deliberately processing them to extract marrow or collect raw material for tool production. This type of bone percussion technology wasn't invented in North America. It was well documented in Africa and Eurasia and had been practiced by early humans for hundreds of thousands of years. Third, they addressed the dating directly. Because the mastodon's collagen had degraded over time, they couldn't use traditional radiocarbon dating. Instead, they used uranium-thorium dating, a technique that measures the radioactive decay of uranium trapped in bone and tooth specimens. This method provided a date of approximately 130,000 years ago with a margin of error of plus or minus 9,400 years. The dating was consistent across multiple samples and was performed by independent laboratories, lending credibility to the results. When the 2017 announcement hit, it sent shockwaves through the archaeological community. Some researchers were genuinely intrigued. Here was a peer-reviewed publication in one of the world's most respected scientific journals, authored by credible scientists with decades of experience. The evidence seemed substantial and carefully documented. Perhaps, some thought, our understanding of human migration really was fundamentally flawed. But many more archaeologists were deeply skeptical. Some were professionally skeptical, which is entirely appropriate in science. Others seemed almost personally offended by the claim. The debate that followed was heated, sometimes even bitter. It became what one Los Angeles Times article famously described as archaeology as blood sport. One of the most prominent critics was Gail Haynes, a renowned expert on the bones of extinct mammals. Haynes questioned numerous aspects of the Cerruti team's analysis. He raised concerns about whether heavy equipment might have caused the bone fractures, whether the site's stratigraphy was truly undisturbed, and whether the dating methods were as reliable as claimed. Other archaeologists pointed out what they saw as gaping holes in the evidence. Where were all the other artifacts you'd expect to find at a human occupation site? Stone tools typically show up in clusters with hundreds or thousands of pieces at any given location. The Cerruti site yielded hammerstones and anvils, but almost no other evidence of human presence. Matthew Magnani and his colleagues at Harvard conducted a detailed analysis of the experimental evidence the Cerruti team had relied on. In a paper published in Antiquity, Magnani and his team criticized the experimental design itself. They argued that to convincingly demonstrate an early human presence at the site, the researchers needed to improve their analogical foundations, test more alternative hypotheses, increase experimental controls, and quantify their results more rigorously. In other words, they weren't convinced the experiments were rigorous enough to support such an extraordinary claim. The core of Magnani's critique centered on what he called the chain of inference. The Cerruti team had shown that you could break mastodon bones using stone hammers and anvils, creating similar fracture patterns to those found at the site. But Magnani pointed out that demonstrating it's possible to create these patterns isn't the same as proving humans actually did so. You also need to demonstrate that these patterns couldn't be created by natural processes, that alternative explanations were less likely, and that the experimental methodology closely mimicked what would have happened at the actual site 130,000 years ago. He questioned whether the researchers had adequately tested whether freeze-thaw cycles, hydraulic pressure, or even carnivore scavenging might produce similar results. The scientific community was essentially being asked to accept a hypothesis based on what was possible rather than what was proven. Other scholars suggested alternative explanations for the broken bones and stones. Perhaps the mastodon had been trampled by other mastodons shortly after its death, causing the characteristic fractures. During the Pleistocene, mastodon herds roamed across North America, and when an individual died or became mired in mud or water, other members of the herd might inadvertently damage the carcass through trampling. The weight of several tons of living mastodon could easily break bones, particularly if they were already weakened by the decomposition process. Perhaps the bones had been scavenged and broken apart by one of the Ice Age's megafauna predators. The short-faced bear, for instance, was even larger and more powerful than a modern polar bear. These massive carnivores had enormous bite force and could crack bones open to access the nutritious marrow inside. Saber-toothed cats, dire wolves, and other fearsome predators roamed the landscape during this period. Any of these creatures could have processed the mastodon carcass, leaving fracture patterns that might superficially resemble human processing activities. Perhaps natural geological processes, freeze-thaw cycles, or chemical weathering could produce the patterns observed at the site. Repeated cycles of freezing and thawing can cause bones to crack. Mineral-rich groundwater percolating through the site could cause chemical changes that weaken bone structure. Movement of sediment layers, pressure from overlying rocks, or even vibrations from seismic activity could potentially fracture bones in particular ways. Maybe the stones were just coincidentally located near the bones and hadn't been used as tools at all. Stones naturally occur in geological deposits, and perhaps these particular cobblestones had no special significance and no connection to the broken mastodon remains whatsoever. There was also a genetic argument against the Cerruti interpretation. If humans really had been in North America 130,000 years ago, wouldn't their descendants still carry genetic evidence of that presence? Yet, when researchers examined the DNA of both modern and ancient Native Americans, they found no genetic signatures that couldn't be explained by the currently accepted migration routes. This suggested that either the Karuti humans never survived long enough to leave descendants, or they never actually existed in the first place. The Karuti team did not remain silent in the face of these criticisms. Stephen Holen and his colleagues published responses to the major critiques. They reiterated that the evidence of pedogenic carbonate crusts on the bones proved the breakage was ancient. Carbonate crusts form over thousands of years through chemical processes in soil, so their presence is strong evidence that the bones had been buried and altered for an extremely long time. They argued that none of the alternative explanations, trampling, scavenging, natural processes, could account for all the features of the site simultaneously when examined comprehensively. They pointed out that human remains are extremely rare in the archaeological record, particularly at very early sites. This is a crucial point that critics sometimes overlook. The preservation of human bones requires very specific conditions. Acidic soils can dissolve bone, alkaline soils preserve it, certain moisture levels are necessary, and cave environments often preserve bone better than open sites. After all, researchers have only found 2 examples of actual human remains associated with the Clovis culture, despite the culture being nearly 13,000 years old and widespread across North America. This means that if we found no Clovis human remains, it would be completely unreasonable to expect abundant human skeletons at a site 130,000 years old. The rarity of human remains at even well-documented archaeological sites raises questions about how much weight we should place on their absence at the Karuti site as evidence against human presence. They also noted something fascinating about the broader context. During the proposed time frame of the Cheruti occupation, the world was warming and sea levels were rising. The Bering Land Bridge, the traditional route for human migration to the Americas, should have been underwater 130,000 years ago. So if humans really did occupy the Americas at that time, they must have either crossed during an earlier moment when the bridge was exposed, or they must have made at least part of the journey by boat. And here's where it gets interesting. During the same period in the Old World, early humans were already capable of maritime travel. There's archaeological evidence that humans had reached the islands of Crete and Sulawesi by this time, which required crossing significant bodies of water. Sulawesi is particularly significant because it's separated from the Asian mainland by deep ocean channels, meaning that anyone reaching it had to have possessed sophisticated watercraft technology, or at minimum, effective floating vessels. Scientists have found stone tools and evidence of habitation on these islands dating back 100,000 to 130,000 years ago, proving beyond doubt that humans were seafarers during this exact period. The implications are staggering. If humans in Southeast Asia could navigate open ocean waters and colonize distant islands, couldn't similar populations have migrated along Pacific coastlines? Some researchers have proposed a coastal migration theory, suggesting that early humans might have traveled down the west coast of North and South America in boats or using coastal resources. This would leave minimal archaeological traces, because many ancient coastal sites would now be underwater due to sea level rise. Evidence of such a migration would be spotty and rare, scattered along coastlines that have been underwater for tens of thousands of years. From a technological standpoint, the idea of early maritime migration to the Americas isn't completely implausible, and some researchers find it even more compelling than the traditional land bridge model. One particularly intriguing piece of evidence came from modern genetic studies of Native Americans. Researchers found that some Amazonian populations carry genetic markers that are different from those found in Central and Northern American indigenous peoples. This suggests the possibility of multiple waves of migration into the Americas, or different populations, arriving at different times. Could the Karuti humans represent one of these early migrations? Some researchers find this genetic diversity compelling evidence that the populating of the Americas was more complex than previously thought, involving multiple founder populations arriving through different routes and at different times, possibly separated by tens of thousands of years. What's remarkable about this entire controversy is that it mirrors other great scientific debates in history. The geologist J. Harlan Bretz spent decades being ridiculed for proposing that catastrophic floods had reshaped the Pacific Northwest, a theory now universally accepted. When Bretz first presented his evidence in 1928, the scientific establishment was appalled. His ideas violated uniformitarian principles that dominated geology at the time. It took decades of fieldwork, mounting evidence, and eventually a complete paradigm shift in how scientists understood catastrophic geological events before Bretz was vindicated. Thomas Dillehay himself faced years of professional skepticism for his work at Monteverdi before most of his peers came to accept it. He endured criticism, doubt, and outright hostility from established archaeologists who believed in Clovis' first theory. Yet he persisted in his research, gradually accumulating evidence that became impossible to dismiss. Today, Monteverde is accepted as a legitimate pre-Clovis site, and this acceptance opened the door for recognizing other early sites. These examples teach us that scientific history is full of revolutionary ideas that faced fierce opposition before eventually gaining acceptance. But it's also full of bold claims that ultimately turned out to be wrong. And the key is distinguishing between ideas that deserve to be taken seriously despite their challenges to orthodoxy, and ideas that simply lack sufficient evidence. This is exactly the tension at the heart of the Cerruti Mastodon controversy. The Cerruti team seemed frustrated by what they perceived as dogmatism in the scientific community. De Marais expressed disappointment at what he called the reluctance of scientists to engage in a two-way conversation to objectively evaluate our hypothesis. Holland acknowledged that he wanted criticism, saying, "We're expecting pushback and expect people to be critical. We want people to be critical." But he seemed to feel that the scientific community wasn't engaging with their evidence on its merits, but rather dismissing it out of hand because it threatened established paradigms. The philosophical question at the heart of this debate is profound. Science is supposed to be self-correcting, constantly revising its understanding in light of new evidence. Yet scientific communities are also human organizations with institutional interests, professional hierarchies, and established frameworks that people have invested their careers in defending. How do you balance openness to genuine revolution and understanding against the equally important need to maintain standards and skepticism about extraordinary claims? This tension is at the very heart of the Cerruti controversy. Some researchers argue that the Cerruti team deserves credit for challenging orthodoxy and presenting evidence that deserves serious consideration, even if that evidence remains contested. They point out that science advances through exactly this kind of bold hypothesis and critical discussion. Others counter that maintaining rigorous standards of evidence is equally important, and that accepting weak evidence just because it contradicts established dogma would lead to equal problems. The middle ground is messy, complicated, and unsatisfying to both camps, yet it's probably where the truth actually resides. The Cerruti site presents evidence that warrants continued study and investigation, but the evidence is not yet overwhelming enough to overturn a century of accumulated archaeological understanding. In 2019, Richard Cerruti, the paleontologist who discovered the site, passed away. Some of the research momentum seemed to slow after his death. However, in 2020, some of the original paper's co-authors published additional evidence analyzing the stones found at the site. They presented results suggesting the rocks bore traces of processing mastodon carcasses, bolstering their interpretation. But this new work did little to convince the broader skeptical community. As of 2026, the site remains contested territory in archaeology. A small but dedicated group of researchers accepts the Cerruti interpretation and believes it represents genuine evidence of human activity at 130,000 years ago. A larger portion of the archaeological and paleontological community remains unconvinced, viewing the evidence as ambiguous and open to alternative explanations. Most textbooks still present the conventional timeline of human arrival, around 13,000 to 15,000 years ago, though many now acknowledge the pre-Clovis sites like Monteverde that push the date back several thousand more years. The San Diego Natural History Museum maintained an exhibition displaying the actual Cerruti specimens from April 2017 through April 2026, presenting visitors with the evidence and allowing them to form their own opinions. In the museum's presentation, the site is described as showing possible evidence of modification by early humans, and visitors are invited to consider the implications if the interpretation is correct. The phrasing reflects the ongoing uncertainty, the deliberate ambiguity about whether this really represents human activity or something else entirely. What makes this story so compelling isn't just the potential rewriting of history, though that's certainly dramatic. It's what the Cerruti Mastodon controversy reveals about how science actually works, how evidence gets interpreted, and how paradigm shifts happen, or fail to happen. Science is supposed to be purely objective, a straightforward business of testing hypotheses against evidence, but in reality, it's conducted by humans with institutional investments in existing theories, professional reputations built on accepted frameworks, and natural resistance to revolutionary change. At the same time, skepticism and critical evaluation of extraordinary claims is absolutely essential to scientific progress. If every bold claim were immediately accepted without rigorous scrutiny, science would be swamped with ideas that couldn't withstand scrutiny. The tension between openness to paradigm shifts and resistance to unfounded claims is healthy, even if it sometimes produces acrimonious debates like the one surrounding the Cerruti Mastodon. The larger question hanging over this entire controversy is one of methodology. How much and what type of evidence is required to prove human activity at an ancient site? Should the absence of certain artifacts, the lack of lithic waste products, count strongly against the interpretation? Or could it be that early humans, working 130,000 years ago, had different practices and left different archaeological signatures than humans of more recent periods? Should genetic evidence be weighted heavily, or could it be misleading if early populations went extinct without leaving modern descendants? These questions don't have easy answers, but they're important ones that push the entire field of archaeology to think more deeply about how we reconstruct the past. Some researchers believe the Rewrote team has opened an important conversation, even if the specific site remains controversial. Others believe the team has spent 25 years pursuing a false lead that distracts resources and attention from more productive avenues of research. If the Rewrote interpretation is correct, it would require us to imagine a very different human past. It would mean that anatomically modern humans or other human species, possibly Homo erectus, Neanderthals, or archaic Homo sapiens, were capable of reaching the Americas and establishing themselves there more than 100,000 years before the populating of the rest of North America. Early humans would have demonstrated incredible resilience and adaptability, surviving in an unfamiliar environment with unfamiliar flora and fauna, different climate patterns, and enormous geographic distances from their original populations. It would suggest that perhaps this early population went extinct without contributing to the later peoples who inhabit the Americas today. Perhaps they arrived during a favorable climatic window, thrived for a time, and then succumbed to environmental changes or competition from later arrivals. Or perhaps they did contribute genetically to diluted or lost over tens of thousands of years. It would radically expand our sense of human adaptability and ambition in the distant past. We would have to acknowledge that ancient humans were far more sophisticated travelers and explorers than we often give them credit for, capable of not just surviving but potentially thriving in completely novel environments on distant continents. On the other hand, if the skeptics are right, the Rewrote mastodon remains a fascinating example of how nature can mimic human activity, how confirmation bias can affect even experienced scientists, and how important it is to maintain rigorous standards of evidence in archaeology. Either way, the site has become a landmark in the ongoing conversation about human origins and migrations. What's clear is that the story of human arrival in the Americas is far more complex and contested than the simple Clovis first model that dominated for so long. Whether or not the Rewrote mastodon proves to represent genuine human activity, it's part of a larger shift in archaeological thinking. Pre-Clovis sites are now widely accepted. The timeline is being pushed back further than it was 30 years ago, and new discoveries continue to surprise us about what early humans were capable of. The Rewrote mastodon site stands as a monument to both the possibility of genuine paradigm shifts in science and the difficulty of achieving those shifts when evidence is ambiguous and interpretations are contested. It reminds us that archaeology is not a finished science with settled answers, but an ongoing conversation between the present and the deep past. Every new discovery, every new analysis, every new methodology brings us closer to understanding who we are and where we came from, even as it raises new questions we didn't know to ask. The bones of that ancient mastodon, broken and analyzed and debated for nearly 3 decades, remain in the San Diego Natural History Museum. They're silent witnesses to a scientific controversy that continues to evolve, and they're a reminder that the story of human civilization is still being written, still being discovered, and still capable of surprising us with hidden truths buried beneath the earth. The Rewrote mastodon site represents a crucial moment in how we understand human history and how science progresses. It demonstrates the importance of challenging established frameworks while simultaneously maintaining rigorous standards for evidence. It shows us that the past is far more complicated than simple narratives suggest, and that archaeological sites can be reinterpreted as new technologies and methodologies become available. Whether those truths ultimately confirm or contradict the Rewrote team's interpretation, one thing is certain. This mastodon has already changed how we think about the science of archaeology itself. Future discoveries may vindicate the Rewrote team completely, or they may prove the skeptics right. More likely, the truth will be somewhere in between, requiring us to accept that human migration to the Americas involved multiple waves, multiple routes, and multiple time frames. The conversation continues, the evidence accumulates, and somewhere beneath the earth, there are still more secrets waiting to be discovered that will further illuminate the remarkable story of human beings and how we came to inhabit every corner of this extraordinary planet.